Welcome to qnawire.
Okay, so we know the magnetic field is equal to mu0 I over 2 pi r. So therefore, the magnetic flux is equal to the magnetic field times the area. Therefore, we have the derivative of the magnetic flux is equal to B dA. So therefore, we know that dA is equal to A dr. Okay, and dr is the elements of the area. So therefore, we have d phi b is equal to BA dr, which is equal to mu0 I over 2 pi r times A dr. Then I have magnetic flux is equal to the integral of the derivative of the magnetic flux. Therefore, we have integral which is range from b to b plus a, and inside integral is mu0 I over 2 pi r times a dr. Therefore, we have phi b is equal to mu0 I a over 2 pi, and then with the integral dr over r inside the integral. So therefore, we can determine the integral here. So therefore, we have phi b is equal to mu0 IA over 2 pi times natural log r range from b to b plus a. Okay, so therefore it's equal to mu0 IA over 2 pi times natural log b plus a minus natural log b. Therefore, we have mu0 I a over 2 pi times natural log b plus a over b. And eventually we'll have mu0 IA over 2 pi and then times natural log 1 plus a over b. And for the next question, while we know the induced EMF is equal to the negative derivative of the magnetic flux over dt. So therefore, we have negative d over dt magnetic flux. Then we have negative d over dt. And what's inside is mu0 I over 2 pi times natural log 1 plus a over b. Therefore, eventually we'll have EMF is equal to negative mu0 IA over 2 pi. And then times d over dt natural log 1 plus a over b. Then we can continue from here. So we have EMF is equal to negative mu0 IA over 2 pi times 1 over 1 plus a over b. And then times negative a b squared. And then times dv over dt. Okay, because the derivative d over dt of 1 plus a over b is equal to negative a over b squared. Okay, and then we keep db dt there, so that's why it's still there. And we know the velocity was along a horizontal direction, since he was saying that the loop is pulled away from the wire at a speed v. Okay, so it's a horizontal speed, which means that it should be the derivative of the horizontal distance, which is dB over dt here. Okay, so therefore we have something here. So we have negative mu0 IA over 2 pi times so here we can just multiply by b here on up and down, so we can keep the values the same and simplify it. So therefore we have b over b plus a, and then times negative a b over b squared, and remember dv over dt should be the velocity, which is the horizontal velocity, so we just put v here, okay? And then as you can tell, b can be cancelled out, and the negative sign can be cancelled out. Oh, sorry. And then eventually, if we do some arrangement here, we'll have EMF is equal to mu 0 IA squared over 2 pi b times b plus a. And it should be velocity here as well. Okay? And according to the right-hand rule, we know the directions is supposed to be clockwise. Okay? And for question D, well, we know the force can be equal to F1 minus F2. So F1 is the force that will be directed toward the left, and F2 is the force that will be pointing toward the right. And we know F1 is equal to mu 0 over 2 pi b times I, and then times the current around the loop, and then times A. And F2 is equal to mu 0 over 2 pi times A plus B, and then times I times the current of the loop, and then times A. So eventually we'll have force is equal to mu 0 I loop times A over 2 pi, and then times 1b minus A plus B. Okay? If we do some arrangement here, we'll have mu 0 I loop times A over 2 pi, and then times B times A plus B. And then what's up here is A plus B minus B. And then we'll have mu 0 I loop times A squared over 2 pi B A plus B. Okay? And then we know that I loop can be equal to EMF over R, which is the resistance. Okay? And this will give us mu 0 IA squared V over 2 pi B times B plus A R. And then we can plug in back to the equation. Then we'll have force F is equal to mu 0 IA squared 2 pi B B plus A times mu 0 I squared V over 2 pi B B plus A times R. So eventually we'll have force F is equal to mu 0 squared times I squared and times A to the power 4 times V over 4 pi squared B squared B plus A squared R. And this is the answer for this question.